On this episode of the WildFed podcast.
The weird wonderfulness of life on Earth. We barely scratched the surface. It's full of crazy, amazing forms of life that scientists aren't studying.
Your menagerie is so obscure.
Plants, fungi, lichens, these are things that you can get up and look at and feel and smell and touch and sometimes taste, and I think that's great.
A lot of these creatures you write about have strange and unusual scientific powers.
They can survive radiation, disinfection with autoclaves, with benzene, alcohol, formaldehyde. The standard surgical sterilization procedure for medical instruments will not kill them.
When you start to get to what's alive and what's not, that I want to be more clear than it is.
Bacteria can be immortal under the right conditions. They're almost like elves, unless killed in battle, they can live forever.
Episode 43 of the WildFed podcast, Creatures We Don't Talk About, with Jennifer Frazer, is brought to you by Surthrival. Everyone knows that testosterone is a crucial hormone in human physiology, but did you know that it's found abundantly in the pollen of pine trees? Testosterone-rich pollen, that same stuff that blankets the landscape in spring, can be used for androgenic hormone supplementation. It's especially useful for people who are considering pharmaceutical hormone replacement therapies but are interested in a natural, side effect-free alternative. Pine Pollen Pure Potency is a formula I developed for andropause support and combines the testosterone and other androgenic hormones found in pine pollen with compounds from other herbs like stinging nettle root that help to free your body's natural testosterone too. Right now until August 27th, all Pine Pollen products at Surthrival are 20% off with the coupon code PINE20. That's the word pine and the numbers 20, PINE20. Surthrival carries a full lineup of pine pollen tinctures and whole powders that can be used for more general nutritional support too. Get it for you, or get it for your dad, or get it for your granddad. Learn more about pine pollen and check out the rest of the lineup at surthrival.com. Hey, thanks for all those 5-star ratings and the incredible reviews over at iTunes. Listen, you only have to do this once to move the needle on how the show gets put in front of new listeners. You just go over to iTunes and hit the 5-star rating, assuming you think that we warrant it, and then write up a short but honest review, and you're done. You're done. Anytime you hear me asking, you can think to yourself, I'm all set. I've already given a little back to support Daniel and the WildFed team and their mission. It's instant gratification. And please know, we read all those reviews, and they mean a lot to us. I'm Daniel Vitalis, and you're listening to the WildFed podcast, a show about reconnecting with nature through hunting, fishing, foraging, and food. WildFed. Food is all around you. Well, I recently had a really fun conversation with Jennifer Frazer. She's a freelance writer for Scientific American who, for more than a decade, has authored the popular blog The Artful Amoeba. She describes herself as an underloved lifeform enthusiast and a poker and prodder of miscellaneous slimy things. If you're interested in what's happening at the strangest levels of biology, her writing is for you. She deftly distills complex bioscience into short-form writing pieces that are fun to read and easy to digest, tackling the life history and the often unusual morphologies and physiologies of critters from across several kingdoms. She writes on lichens, amoebas, slime molds, spirochetes, and even the non-creatures too, like viruses and prions. Here we discuss several topics that I have an interest in, but have found difficult to get to the bottom of. Some of my questions are taxonomic, like how do we define the creatures living in the gray area between different kingdoms of life? Or how do we scientifically name organisms like lichens that are actually composites of several other organisms? We also spend some time on a topic I'm both inquisitive and concerned about. That's prions, the non-living mutant proteins that cause diseases like mad cow or its human form, variant Creutzfeldt-Jakob disease. They've also become particularly concerning to me as the cervid prion disease known as chronic wasting disease is making its way across the continent, changing the way we think about deer and other cervids. And then, perhaps most interestingly, we discuss some of the strange discoveries taking place at the fringes of neurodegenerative disease science. Could some Alzheimer's and other progressive neurological disease cases be contracted from surgical equipment contaminated with strange, non-living protein structures left over from other patients' surgeries? While perhaps not as eclectic or complete as the catalog of organisms she's written on over the last decade, this conversation is wide-ranging and traverses the landscape of bizarre and unseen entities that lurk beneath the scale seen by the naked human eye, which, despite their diminutive size, can have profound implications for our health and maybe even reshape our perspective on what the planet we're all born to is actually like at the microscopic level. It's the same theme I'm always talking about here on the show, connecting with your landscapes and the organisms that live there, except that this is in miniature. Jennifer Frazer, welcome to the show.
Thank you. It's a pleasure to be here.
You are a very, very fun and cool writer. I've been going through articles of yours, and you are just such a unique character. I would love it if we could start off by you describing a little bit about, I guess, first what you do and what your writing is, and then we'll get a little bit into sort of who you are.
Sure. So my name is Jennifer Frazer, and I'm a freelance science writer, formerly a blogger for Scientific American. I did that for about 9 years while their blog network lasted. It closed down recently at the beginning of June, but I'm still doing freelance contributions to their opinion section, something you might call an essay or a column, I guess is the word I'm looking for. And my first one was published about a week or two ago on brittle stars. There's a species of brittle star that can see with its whole body, which is kind of fascinating.
What's a brittle star?
A brittle star is an echinoderm. So they're relatives of starfish, and they live in the ocean, and they have 5 very squirmy arms, and they crawl around looking for delicious things to eat.
I'm so tempted to already digress down this rabbit hole, but I want to continue. I want to continue on. So your column that you wrote was called The Artful Amoeba, right?
Yes.
And that was for how long? 9 years?
9 years for Scientific American, and I had done it for 2 years prior to that independently. So I did it for 11 years.
How do you describe this blog to people who ask? Because I think you just gave us a very mild sort of description, but it's a pretty wild place from what I've seen.
Yeah, so the tagline was a blog about the weird wonderfulness of life on Earth. And it really grew out of my discovery when I went to college and grad school that there was this whole world of life out there that was utterly fascinating to me that no one was talking about, not even biologists. Not even biologists. Like, I wanted to study these critters, and it wasn't a topic that came up in the majority of my biology classes. And part of that is that biology has moved from the world of natural history, which is where it existed for most of its life, into the world of predominantly molecular biology now. And we've kind of gotten away from an organisms focus and into a a cells focus. And
could we break that down a little bit more? I think that what you just said, maybe in the scientific community, that's just sort of like obvious, but for the layperson, I don't think it really is. Could you explain maybe a little more at length what you mean by that? That's sort of the difference between molecular biology and natural history, and then what that change has looked like functionally?
Right. So in the 19th century and for most centuries prior, most biologists were interested in going out into the field and discovering new forms of life and describing them. And that was pretty much biology. And for a long time, that was plenty of work for everyone. But then we had, in the 20th century, discoveries about how cells work and how the cells work contribute to how organisms work. And people started to get more interested in the cells rather than the organisms, and what was going on at the level of the cell, and even smaller than that, at the level of the molecule, at the level of DNA or the level of protein. And that's kind of where biology has predominantly headed. Part of that is because of the human focus. We're very interested in curing disease and understanding how genetics works and all kinds of different things, and rightfully so. But the dollars for science, for biology, have followed that, and they've pretty much big research funding agencies have pretty much abandoned funding this kind of basic natural history biology that was predominant for so long. So that's kind of where we are today. And I should add that as research dollars have gone, so has biology instruction within high schools and colleges. In the old days, when you would go to science class and learn about biology, you were learning natural history. You were learning about, the birds and the bees, literally the birds and the bees this time,
Right,
actually.
the actual ones.
The actual birds and bees. And now, even when I took high school biology and college biology 20 years ago, there was a biodiversity section in those textbooks, but either we never opened those chapters or we kind of, really quickly brushed over it. So that's the kind of stuff that I'm interested in still today, because the truth is, even though we studied those topics for hundreds of years, we still didn't, we barely scratched the surface of what there is to know for most of life on Earth. And by that, I mean the stuff without backbones, non-vertebrates.
So this would be like if you were tasked with studying a person, and rather than spending time with them, getting to know them, meeting their friends, seeing their home, seeing how they move through life, instead you studied them at maybe the genetic level or looked at their demographic data. Is that sort of metaphorically like what you're saying?
Yeah, but instead of studying, say, all humans this way, you were studying the people that lived in this one neighborhood in Chicago. Because now, there's a handful of model organisms, right? So we have the mouse. There's also the roundworm, C. elegans, the fruit fly. There's a few others like this, and these are the organisms that are getting studied. They really want to, the way that the genome works. Thousands of genes split between chromosomes in the nucleus of a cell. The nucleus is like the heart of the cell where the DNA is kept. It's extremely complicated, and scientists rightfully are struggling to understand how those genes interact with all the rest of the contents of the cell to make an organism go. And it's so complicated that it's all they can do just to focus on, these 5, 10, 20 model organisms. And that's what they've been doing for the last 50 or 100 years, is focusing on just these, 10 or 20 different organisms. But all these other, the rest of the population of the planet is basically going unstudied right now. Now, that's kind of an exaggeration, but I think it drives home the main idea.
Do we study these organisms due to specific traits, for instance, like similarity of our genes to mouse genes, or generational replication of a fruit fly is useful? Are there specific traits for that are why we specifically focus on these organisms?
I think the reason that we've picked these organisms is that they're most relevant to understanding humans at a given level. So there are levels for which a mouse is a useful model for a human, but sometimes you need to get even more basic than that mouse, and that's where the roundworm comes in. They're even more simple, when you really, I just can't understand how this particular circuit of this system works. I need a really, really basic model so that it's really clear to me what's going on. I can eliminate all these other things that might be happening in a mouse or a human so that I can understand this part of how this animal is working.
Okay. And then to make sure I understand fully your whole point as we circle back, and I know I've already got you on a tangent here. I want to get back to your education and background, but I guess as I hear you say this, I'm sort of thinking about the difference between knowledge and wisdom, information and wisdom, and that it's like the tree, seeing the trees but missing the forest maybe a little bit if we lose the natural history piece. But I want to make sure I understand sort of how you see it. What are the downsides? Because I felt like implicit in what you were saying is like there may be some downsides to this myopic focus that we've got now in the biological science. Did I misinterpret that, or is there something there that you feel like is getting us off track a little bit?
I think that scientists have done what they have done for extremely good reasons. But I think as humans, we have lost out on something, because They're trying to understand how the supercomputer that we call a human works. And that's important and noble. I don't mean to undermine or undercut the importance of that. But as humans, we also live on this planet, and it's full of crazy, amazing forms of life that scientists aren't studying and that don't get brought up in high school biology. And when humans don't know about them, they almost don't exist for us. And I think that not only hurts the planet and those life forms, it hurts us. It hurts us a lot. And another trend that has compounded this problem is the lack of exposure to nature in children. By children. And this is actually, I think it's something that's totally unrelated to what I've just told you is going on in biology, but they have worked synergistically to really, really destroy the connection of humans to wild places and nature. And, when I was a kid, I don't know about you, I was basically, I was almost feral during the day. My mom would kick me out of the house in the morning, and I would go spend, granted, I was lucky, I'm privileged, you might say. I lived in a rural place. I was in Southeast Tennessee till I was 6 years old. And we were like the only people at the end of the road, and we were totally surrounded by woods. But I think I was only 3 or 4 years old when my mother did this. And I was out in the woods all day, just by myself, with nature, poking around, looking at things, just sort of laying on rocks, looking up at the trees, listening to the wind. And that time with nature that I think a lot of kids have lost for many, many reasons that I probably don't have to explain to you, is another thing that has kind of cut us off from discovering these life forms in nature and like developing a connection with them and a curiosity about them.
There's so much I want to say in response to all that, but I want to make sure I keep the continuity. But I'm really on board with what you're saying, and I appreciate the observation about the intersection of these two things: this change in the sciences, and then this sort of nature deficit that we've developed, because they do seem to work synergistically, or I guess whatever the opposite of synergy is, because they're sort of kind of negatively interfacing. But I guess when we're talking about the nature connection, going back. I remember growing up, so many kids, you'd be like, what do you want to do when you grow up? And they'd be like, marine biologist, everybody, marine biologist. I want to work with dolphins. I want to work with sea turtles. Everybody attracted to these bold, beautiful, sort of iconic creatures. And I'm curious because your menagerie is so obscure, and it seems like you are just drawn to all the sort of the oddballs in the natural world. Now, a couple things come up for me in what you were saying before. One is a study that had come out recently. It was talking about I only have tertiary knowledge of it, but anyway, it was talking about how in urban environments, a lot of times kids are, if you ask them about animals, they'll start describing animals from other continents before they'll mention any animals from their own landscape. Just because they typically don't know the animals from their landscape and have a negative view of the ones that they do know, like pigeons and raccoons. But they're, real quick in New York City to say giraffe and zebra and lion, but they don't know the animals from their own landscape. So as we've become more and more nature disconnected, not only do we lose sight of all of that megafauna and sort of medium-sized animals and even small animals from our own landscape, but certainly we're not even aware of this strange menagerie that you write about. And then the other piece I want to say on that is just going back to another thing you said. A lot of these creatures you write about have strange and unusual scientific powers that seem so beneficial to where we're headed culturally and scientifically. It seems like there are more breakthroughs that are going to come through lichens and prions and all of these amoebas and creatures like that than are going to come from studying zebras and lions at this point. So it's kind of sad that we're missing all that. But anyway, going back, how did you get to this place? What are your degrees in? And as a kid, were you drawn to the Underdog, or is this something different?
No, so as a kid, I had no awareness of these creatures at all. I would say I spent a ton of time in nature for a kid, for which I'm so grateful. But I didn't really, I wasn't particularly drawn to these creatures at that time. I just liked being outside and being in the woods. And I remember at one point, I think when I was maybe 8 or 9 years old, I built like this special, I mean, I think a lot of kids did this back in the day. I built this special little secret place just for me, like, a little house made of wood, and I collected little mosses to make it like soft and nice and cushy, and almost like a bowerbird construction, but for like a little girl. And
Yeah.
and so, I mean, I think the time I spent outside was really important for cultivating just a general love of nature, of being outside. But it wasn't until I got to high school and I started studying biology that I started to get really interested in these kind of oddball creatures. Although I would argue oddball is definitely a very biased human word for these things, because in a lot of cases, they're probably way more abundant than we are. And they're probably
Right,
way more
right.
important to the ecology of the planet. Um, yeah, so I got to college. I knew at that point, I was pretty sure I wanted to study biology. I also thought about studying archaeology because I'm super interested in history. But I realized that I would have to live in like some really far away places to study the archaeology I wanted to do. Whereas if I studied biology, I could just stay here. And I ended up doing that. And by the time I finished, I got a bachelor's degree in biology at Cornell University. And by the end of that time, I had realized I had this particular love of biodiversity, I guess is the word that I'm looking
Okay.
for. I I was supposed to pick a specialty, and the specialty I chose for my major was general biology because I just didn't want to get pigeonholed into
Yeah.
one thing. And I didn't really, I had realized I thought I was going to become a biologist. And I had worked in 2 or 3 different research labs. And at first, I really enjoyed it because it's a lot like cooking, when you're a lab
Hmm.
tech, it's a lot like cooking. Here's your recipe, just follow the instructions, and at the end, you'll get your data, your result. But as I got further up in the hierarchy and I realized, as I began to have to do my own research, I realized that a biologist today is nothing like a biologist of the 19th century. You can't be Ernst Haeckel anymore. You can't study 100 or 1,000 different kinds of creature. You have to pick one, and you've got to study one little aspect of that one creature. And I couldn't do that. It was just
Mm.
too soul sucking for me. And not only that, I mean, wow, in the 19th century, these guys had lives, and apologies to all biologists out there, but I feel like scientists don't have lives anymore. Like they're working 60, 80-hour weeks. They're working their fingers to the bone, writing grant applications. It's only gotten worse the last 20 years in terms of the research dollars available. And that wasn't the life I wanted. Like a lot of your listeners, I like being outside. I like
Hmm.
seeing nature happen in front of my eyes. And I tried to think of how can I, combine those two things. And another thing I thought I was pretty good at was explaining biology to other people. I had worked as a teaching assistant in biochemistry and general biology in undergrad and grad school. And I thought it occurred to me several times. I had a subscription to Discover magazine in high school that I really liked. And it occurred to me several times, maybe I could be a science writer. Maybe I could just write about all these, wonderful things that I want to tell people about. And I ended up stalling by going to grad school, a well-worn path that many people have used in the past. But I did it in a way that I could keep learning about all these crazy things. I got a master's degree in plant pathology, which
Wow.
people always mishear as plant mythology, which is a very different subject.
Whole different podcast right there.
Yeah, no, plant pathology is the study of diseases of plants, right? And the reason I picked it was because I thought it would give me the chance to study the maximum number of these sort of weird, interesting organisms, because there's a lot
Ah,
of weird,
you
interesting
were
organisms
the infectious agents.
that infect plants, right? And plants
Right.
also are really neglected. I mean, they're not as neglected as a lot of microbes. But I mean, when I was a blogger, anytime I would write a plant post, they were the lowest traffic posts that I ever,
Yeah.
even if I thought this is a
Right.
fascinating topic, like plants just put people to sleep for some reason, which I think is totally undeserved. They have really interesting biology on their own. But anyway, they also have some really interesting pathogens. And so I did this. I got a master's degree so I could study these things. And also while I was there, I took for the first time mycology, which is the study of fungi, and field mycology, which is going out into the field to look for fungi, i.e. usually mushrooms, although there's a lot of other things. And
I would
that
have
was
always thought this was the same thing, by the way. I would have assumed that mycologists did go into the field. I've only recently come to understand that these are separate things.
very separate for the same reasons I've explained earlier. The real mycologists are usually drilling down into the molecular biology of these organisms. The field mycologists, well, they don't, for the most part, they don't really exist anymore. There are a few, but actually, I'll tell you, most of
a
the
lot
ones,
of them are lay people now, though,
that,
right?
that's what I was about
amateurs,
to say.
right?
Yes, the field mycologists that exist are lay people. There's actually a famous field mycologist named Michael Kuo, whose day job, at least a few years ago, was an English professor. And then in his free time, he studied morels and did all the science, So it's
similar with lichens now too, is it not? I had a lichenologist on recently who's an amateur, and she was sort of saying that a lot of the folks who are doing the work there now are amateurs.
Yes. So that was where I first ran into mushroom foraging or hunting. Although we weren't doing it, for the purpose of looking for just things to eat. We were doing it for science. We were collecting as many different things as we could to take back to the lab, to identify, to look at under the microscope, and hopefully to submit a few specimens to the herbarium at the university. That was part of our project. And I discovered that I loved it. Oh, it was great. I was like, look at this. I'm outside. It's almost like, I mean, I probably don't have to tell you or your listeners this, but looking for mushrooms and other fungi is a bit like being on a biological scavenger hunt or Easter egg hunt, where you never know what you're going to find. And it's so exciting when you discover all these things that you've never seen before. You don't know what it is. It's cool looking. I can say. Oh, and I'll tell you another. I'm getting so excited I can't even speak straight anymore. Another reason I study these oddball creatures as opposed to, say, dolphins. Well, I don't live in Hawaii on the west coast of the Big Island, where the spinner dolphins swim into Kealakekua Bay on a regular basis, and I can just waltz down and look at them. But I live in a place where I can go into the forest, and the mushrooms are there, and they don't have wings, and they're not going to swim away. I can pick them up. I can look at them. I can smell them. I have a lot of friends who are birders, and I love them, but I will never understand the appeal of squinting through binoculars at this thing that's like half a mile away, and it flies off before you can even get a good look at it.
Yeah. Check it off in your book, though.
Yeah, exactly. Plants, fungi, lichens, these are things that you can get up and look at and feel and smell and touch and sometimes taste, and I think that's great.
It's interesting with fungi versus plants in how they're perceived, because I'd agree with what you were saying before. I was talking to somebody about this recently on the show, how if I post something on social media about plant foraging, it doesn't really get people too excited. But you post a picture of mushrooms are just so photogenic, and people get so lit up. But then I think also the experience of going out after them, going out for mushrooms is a lot more akin to hunting than it is to foraging for plants. I don't know there's just something very different. I don't know if it's in
I'll tell you what it is.
Psyche.
It's the unpredictability of it. It's the unpredictability of it, because plants, they're pretty much always in the same place year to year, right? It's not a mystery
rooted.
Where your blackberry patch is. It's there every year. Maybe the blackberries are better some years than others, but there's no mystery. There's no art to finding them, right? Whereas with mushrooms, you can go and find a patch of morels or porcini or whatever, and then the next year they're not there. Or, where have they gone? Or you find a certain kind of mushroom that you've never seen before in a new place. I think it's the element of surprise, of not knowing if you're going to find it or not, of finding something completely new that you've never seen, even though you've been there a million times. I guess fungi are almost like animals in that respect, that
Yeah.
they don't exactly move around like animals do, but they you just don't know when they're going to decide to pop up and show you they're there.
Their parts also, their fruit bodies often look more like animalia than they do like plant,
Oh, and
there's,
fungi are way closer related to animals than plants are.
yeah. Yeah, I think you can really feel that in the experience of working with them,
Hmm.
and also in cooking them, because from a culinary perspective, they're so proteinaceous that you have the experience of eating something that's more meaty than with most
Yeah,
plants, right?
that's true. Hmm.
But all right, so then you got into the writing side. Did you immediately start going down the road of writing about these sort of strange and unusual organisms?
No, no, no. Uh, I couldn't see a real plausible way to do that straight away and support myself. I needed a salary job. So, and I love being a generalist. And so while I was in grad school at Cornell, I decided I would join the student newspaper so that I could get some experience, right away, writing about science. And I discovered I absolutely loved that atmosphere in the newsroom. It was full of really smart, really funny, really sharp people who could write well. And it was just tremendously enjoyable to be in there. And so I made it my goal to become a science reporter at a newspaper to get started anyway. I thought that seems realistic. I can have a salary that will pay the bills, and I can get experience writing, and then maybe further on down the road, I can write my book once I get more experience or do something along those lines. So I went to grad school, grad school part two at MIT, and I did their science writing program. And at the end of that, I got an
Wow.
internship at the newspaper in Louisville, Kentucky, the Courier Journal, and I did
Okay.
that for a summer. I mean, and this is the kind of things you write about at a general newspaper where you're an intern, very, very far away from science. You're writing about house fires and car accidents and, you
Right.
know,
Okay.
new like local history museums that have opened up. But, I tried to view
You're
it,
learning the craft of writing,
you're
though.
learning the craft of writing and interviewing. And I tried to view it as, what do they say when, they make you eat your vegetables when you're a kid, builds character.
Yeah.
It was character building, right? So after that, I ended up getting a job at a teeny little newspaper in Cheyenne, Wyoming called the Wyoming Tribune Eagle. And I was their health and environment reporter. Uh, and I did that for
Closer.
about 3 years, closer, right? Although I still had to cover the Wyoming Senate when it was in session for 1 to 2 months of the year. And that was,
Boring.
well, frequently, yes. Yeah. I can remember there were several times I wanted to chew my own arm off to get out of some of those committee meetings. But again, character building, right? And I did
Yeah.
learn a lot about how legislation works.
Yeah. Yeah.
So
Which is good to
anyway,
know.
the good thing was I got a chance to start writing more about science, and I was in the West. It had been my dream to move out west, and at the newspaper in Wyoming, I was not only writing in the West, I was writing about science in the West. I occasionally got to do some science stories. I ended up doing a piece about, I don't know if you remember this. I think it happened around 2004, but it was the wintertime, and there were hundreds of elk in southeast Wyoming that were suddenly paralyzed in the middle of winter, and they started dropping down. They didn't die outright, but they were paralyzed and they would fall down in the snow. And Wyoming Game and Fish didn't know what to do. They didn't know what was causing it. They had no idea. These elk had some really strange symptoms too. They had red urine, but it wasn't blood in the urine. And that was also totally bizarre. And it took them a long time to figure out what had gone on. And I ended up writing a 2 or 3 part investigation after they figured it out about that, right before I left the paper, for which I ended up winning the AAAS Science Journalism Award. And I was so
Oh, wow.
happy that I was able to do that. It turned out what had happened was it was an unusual winter without much snow. And the elk were kind of pushed into an area, possibly by some oil and gas development that they hadn't normally been. And the snow was so low that the ground was exposed where it normally wouldn't be. And these elk were really, really hungry. And I mean, they were desperately trying to figure out, they were considering all kinds of hypotheses like snow snakes, like all kinds of weird, crazy
Snow
ideas.
snakes.
Yeah, snow snake. But what it turned out
It
to
could have been a
be,
Sharknado. I would be
yeah,
worried it's
yeah,
a Sharknado.
exactly. But what it turned out was these elk had been eating lichen that had been
I was like,
exposed.
this has got to be a lichen story. It's got
Yeah,
to
it
be.
had been exposed because the snow wasn't as high as it normally was. And these lichens apparently poisoned them or paralyzed them in some way. And I mean, it ended up being really sad because they were permanently paralyzed, apparently. And so game and fish ended up having to go in and put, dozens or hundreds of them down because,
Wow.
the coyotes were coming in and just starting to,
Eating them
eat.
alive.
Yeah, exactly. So it was kind of freakish, but it was a very interesting story science wise. But it was also a story I think that a lot of readers were really fascinated by because it had this mystery detective element. So, I mean, that was probably the best example of where I got to kind of combine my passion for these odd organisms with my job at the time.
That also it just sounds like also that's where you start writing about lichen and you start going down these strange roads at that point.
Hmm. Well, not quite yet. I ended up leaving that newspaper after 3 years, and I took a job as a science writer at the National Center for Atmospheric Research in Boulder. And I was actually writing about earth science for them. But around that time, I had just won the AAAS award, and I went back to Boston to claim the award. And while I was there, I was talking to some of my old professors at MIT and telling them about this biodiversity project idea that I had for a book and how intimidating that was. And I didn't know how I could do it in my free time. And one of the professors said, "Well, why don't you start a blog?" And I said, well, that's a thought. The one thing I was concerned about was finding images because I was always so big on having images and video. I think aside from names, seeing these creatures is the
Right.
second most important thing for people
Crucial.
to understand what they're like and that they're real and that they're amazing and that they have some pretty amazing anatomy and biology. And I wasn't sure that I would be able to get the rights to images, but it ended up that was not as big of a stumbling block as I thought it was, and I took his suggestion seriously. And when I got home, I started my blog independently in, I believe, 2009.
Okay.
And that was when I said, okay, now I'm going to write about all these organisms that I've been wanting to write about since I left college.
Undersung heroes.
Mm-hmm.
Yeah. So give people kind of a sense of who falls into this category, or how do you look? How do you? I guess what's the phylogeny in your head? Like, how do you organize all this stuff? Like, how do you think about what it is you're writing?
I guess I don't really think about it or organize it in my head. I just kind of write about what pops up as I go along. My main source of ideas is the press release news feeds from the universities.
Oh,
And
okay.
I actually just go through those every week looking for papers that I think are fascinating that the mainstream media has missed because
Yeah. Right.
they don't have my biology training and they didn't realize what was in front of them. And
Right.
that has been my bread and butter these 11 years are these sort of missed papers.
Yeah, because it's like a unique. You have your educational pedigree, which is obviously crucial to what you're doing. Your writing ability, your personality, all these things have to come together just right for you to even pick up on that these are missed stories in a sense. But
Mm-hmm.
um, yeah, I find all this really fascinating. I want to ask you about your perceptions of charisma in living things.
Mm-hmm.
We're all super guilty of this. I'm sure you can relate to it, even though you sing the hymns of these strange creatures. But
Uh-huh.
yeah, it's really easy to see the bald eagle. It's really easy to see the
Mm-hmm.
blue whale or
Mm-hmm.
whatever. And I've noticed on the conservation side and the environmental side that it's really easy to champion an organism that's easy to look at. But if you're the blobfish, like you're just you can raise money for baby seals. How do you raise money for the blobfish? That kind of a thing, right? It's like very difficult for these animals that aren't charismatic. So I assume I'm just guessing you've spent a lot of time, more time than me, thinking about what's charismatic and what's not. So I'm just curious if you have any thoughts about that and how people respond. Is this like an anthropomorphizing of things that makes people relate so much to some organisms and not others? Or, what do you think's going on for us psychologically with all that?
I think you've hit the nail on the head when you say that it's things people can see easily. So, when I just got back from a fishing trip, a very unsuccessful, but still highly enjoyable fishing trip on Dillon Reservoir. And while we were there, hanging out, chilling, and not catching Arctic char,
you were char fishing.
Yeah, trying to. And there was a bald eagle that flew over us, and it had clearly the outline of this perfect, huge fish in its claws, like a fish from the side of a fish restaurant, that kind of a fish.
Right,
and it just motored right on over us. And we're like, oh my God, look at that bird. How is it holding that huge fish? It was just wonderful. I mean, anyone can look at that and get excited, right? It's exciting. It is.
Yeah.
The problem for these other organisms is they're either in places that are hard to see because the deep ocean, it's hard for people to go there, or they're really small. And the only people who have studied them are not good at writing about them. They write about them in highly convoluted ways in very obscure journals. And it's only if you know how to read what they're writing that you can see it and be like, oh my God, this is amazing. This is hilarious. This is extraordinary. If I could just say this in plain English to you, you would be excited too. At least that's how I feel about it.
Because that's how your articles come across. They're very exciting, very fun to read, and they're extremely approachable. So having, as somebody who occasionally reads scientific papers, I have learned over time to be like, oh, this person's getting a little passionate right here in the subtext, between the lines, or where you see somebody's excitement about something, or but it's dry reading for most people. Anyway, you do a really, really good job of that. So I appreciate you making this stuff approachable. I want to, I don't know how to segue easily into this, so I'm just going to bring it up. I have this, I mentioned recently I spoke to a lichenologist, and I was like, but what are they though? Because if you like, it has a Linnaean name, right? It has a binomial Latin name, but it's 2 to 3 organisms.
Oh, could be a lot more than that.
Okay. So, all right. This was actually a setup for another question. So now I'm going to wait on the other question because I'm going to ask you this. Do the individual organisms in a composite organism like a lichen, yes, okay, do they have individual names, or do they exist as individuals separate from the composite anywhere, or are those individuals only found in composite, and do they not get named?
The answer is yes and yes, I think.
Of course it is.
So
it's like I'm comfortable with Bon Jovi is all the guys in Bon Jovi, and then I'm comfortable with Bon Jovi can leave it and he's John Bon Jovi. Do you know what I mean?
That's a great way of saying it. That's awesome. That's perfect, because a lichen is a fungal co-op. The fungus runs the co-op, and then there's a bunch of other members of the co-op that live inside it. So because the fungus built the house and runs it, it's the one that the co-op is named after. But there's a lot of other occupants inside, and most of them can exist on their own. Not so for the fungus. In most instances, the fungus cannot exist without its occupants. But the other people in the house do live freely, which brings the question, what exactly is that relationship? Is it like, this happy, friendly, I'll help you if you help me? That was sort of the classical model of a lichen. Or is something more sinister going on there? Is it more like, this is kind of a loaded term, but, is the fungus kind of enslaving the algae, or is it something even more complicated where there's elements of both? It's not. Or
could it
clear.
Be a domestication, which is sort of like between slavery and freedom? Right?
Yeah. Is it more like a farmer and his crops? Is that more the relationship? And not clear exactly. But
Because
one
the
thing,
algae is the energy producer for the fungus. It's photosynthesizing.
yes, it
Okay.
is the one that's photosynthesizing and making sugar. But the fungus is also providing minerals to the algae, just like the fungi that cooperate with tree roots, the ones that
Mm-hmm.
make mushrooms,
Like
a lot of
mycorrhizal
mushrooms,
ones,
the
right?
mycorrhizal fungi, right? And it's allowing that alga to live in an environment that it almost certainly would not be able to live in otherwise, like the
Okay.
sun-baked surface of a rock in a desert. That's not
Right.
a place that an algae is going to have a lot of success on its own. But inside this, fungal house, yeah, you can make it go. In fact, they do pretty well.
Wow.
What has recently come to light, I would say just in the last 10 years, is that there's a whole bunch of other uh, people, and it's not quite the right word, but players in the lichen, in the fungal co-op. There's bacteria, there's yeasts, and in some instances they make the
So the yeast, sorry, but the yeast would be a fungi, same kingdom, but another species of
yeah,
fungi that's cooperating with the
yeah,
main fungi who runs the house.
you got it, you got
Because
it.
I think of fungi as being very exclusive. Like there's no, it's one of us. There's only room. There's only room on this, on this patch for one of us. So it's interesting that they are sharing space inside their fungal house.
Well, a yeast is a single-celled fungus, so it's a
Mm-hmm.
very different kind of a I mean, there's certain
Okay.
fungi that can exist both ways. They can exist as filaments, the way most fungi do, or they can exist as little single cells. Um, but it's a very, very different form of life than the fungus that's building the
Okay.
lichen. So I
Got it.
think it's yeast are almost like microbial fungi. So
Right.
that is what enables a different species to live there. Although I will say there are also parasites of lichens. There are lichens that are parasitic on other lichens, and they kind of invade and live on the surface. And you can actually see this on rocks. You can see the parasitic lichen in the center, kind of eating its way out, consuming the other lichen that sort of paved the way for it. It's amazing. I love your Bon Jovi analogy, though. I think that's just right. It's
I
only
don't know
Bon
why.
Jovi if Bon Jovi is a member, but everyone else can leave and a new guy can come. It's still Bon Jovi.
I don't know why that was what came into my head, but it did. All right, I want to come back to lichens because I want to talk about prions.
Mm-hmm.
But first, I want to ask you. I'm asking you because of you're a generalist. I'm asking you a bunch of general questions that
Yeah.
can't seem to get answered anywhere else, and you're doing such a good job. So I'm gonna
Oh,
fire
I'm
another
glad.
one at you.
Sure.
What's up with this kingdom we call the Protists?
Uh-huh. What's up with that kingdom? Well, I have some bad news
And
for you.
can you explain to everybody too? Because it's like very simple to understand the other kingdoms, right? So
Uh-huh. Um, Protist is no longer a kingdom.
no,
I know. I'm sorry. I'm sorry to be the bearer of bad news.
no, oh, Protus and Pluto, you're all going away together.
I know, and
Okay,
it gets worse, actually. There's only bad news from the human perspective when it comes to the taxonomy of protists, because what we have realized is that the majority of the diversity of life on Earth is microbial. And most of what we see when we look out our windows is not microbial, but it's just a teeny tiny section of the life family tree. So now when you look at the life family tree, there's like this little backyard that's plants, and then there's another little neighborhood over here that's animals and fungi. And then there's this huge shrub with all these other names on it that are things you've never, ever, ever heard of. And those things are the bacteria, the archaea, and the protists. Protist is just a convenient non-scientific term for all microbes that are not bacteria or archaea. So bacteria and archaea are kind of their own thing. They're very morphologically, they're much simpler than the rest of life. When you look inside their cells, they're very simple compared to everything else. For the most part, they've got DNA, they've got some ribosomes, and that's about it in terms of, the basic bacterial or archaeal cell. Whereas when you look in a protist, say an amoeba, right? You've got lots of furniture that's very different than inside a bacteria. There's the nucleus where the DNA is kept. There's the tongue-twisting endoplasmic reticulum that you may remember from high school biology.
The ER.
The ER, which is very different than the human ER, where proteins are manufactured. There's all kinds of other little. The word in biology is organelles. They're little cell organs. So protists are the life forms that are microbes that have this fancy furniture inside their cells. And what we have
actually, wait. One other thing though is that the phycologists I've spoken to told me that the marine macroalgae, all the seaweeds, are protists.
That's an argument.
But then my botanist friend is like, no, they're plants. And I'm like, they're telling me they're protists. He's like, Daniel, they're plants. We'll get right back to the show in a minute, but first, imagine you had a secret chamber in your home where you could sneak away to calm, detoxify, relax, and revive yourself. It kind of sounds like science fiction, but that's how I imagine my sauna. It's one of the ways I relax my nervous system, retune my immune system, accelerate the elimination of metabolic and environmental toxins from my body, and make myself more physiologically adaptable. I think an infrared sauna is one of the best investments you could make in your long-term health and well-being. But choosing a sauna for your home is a really serious decision. You want to invest wisely. Well, I've been using Clearlight saunas for almost a decade and can personally attest to their quality, fit, and function. These are beautiful units, come in a size that's perfect for anyone's home. They're a breeze to set up, they look great, and they come with a lifetime warranty. But most important, they feel great to be in. If you're considering a sauna for your home or just want to learn more about the ultra-low EMF technology built into Clearlight infrared saunas, go to healwithheat.com. You can always use the coupon code WildFed for $500 off any regularly priced model or $100 off any sale prices. Plus, shipping is free in the continental United States. Now, back to the show.
As a person who studies this a lot, I think that the most helpful way to wrap your mind around it is to stop trying to classify a lot of these organisms as being A or B and just call them like the specific thing they are. Right, because it's, first of all, it's a spectrum, right? Mm-hmm. Where do you draw the line between this or that or the other thing, with animals and plants, it's often easy to draw that line because you can say this adaptation is where we draw the line, this morphological innovation. If you have a backbone, you're in this group. But with a microbe, it's harder. That's not always clear. Or even with bacteria or archaea, it's a lot of shades of gray. And where do we draw the line? We're actually drawing these lines, calling this or that, because it's easy. It makes things easy for us as humans. We need to name them. We need to have categories. But in the real world, maybe those categories don't really exist. We're giving them names because it's helpful to us. And I am 100% a believer that we should name organisms, like real names, not numbers, because for humans, it's very, very important that things have names. But on the other hand, I also think that people need to understand that life is a spectrum. And that doesn't mean we can't still name parts of it. My friend Nathan Peplow, who wrote the Peterson Field Guide to Birdsong, and I were having a debate about this. And I was saying, how can we give these categories names? And he said, well, it's like the color spectrum. The rainbow is a spectrum, but you can still say this part is red and this part is yellow and this part is green. And I thought that was such a helpful analogy because, we can still say birds or snails or, whatever, even though we can acknowledge that maybe it's not always quite so clear when something is or isn't in a certain category, especially when it comes to protists, where things get gray really fast.
So has the kingdom actually been officially removed?
Well, it depends what you mean by official, right? Like who's in charge?
Yeah, there's nobody in charge.
There's no one really in charge.
My best kept illusions.
Okay, so in the world of animals and plants, there are officially people in charge. There are taxonomic governing bodies that have rules for all these things. But I'm not sure that there is an equivalent organization for classification in the world of protists. And there's a guy named Thomas Cavalier Smith who has done a huge amount of work on the evolution of these groups and totally upended the old classifications and created all kinds of new taxa. A lot of his work is extremely dense and hard to understand, even for people like me. But if you go by his system or any number of other systems, we're looking at like dozens of kingdoms of protists now. If you want to, use that word still,
Of
they would.
kingdoms.
Yeah, they probably wouldn't even want to use the word kingdom anymore because that old 7 rank
Oh,
system is
wow.
just totally
Yeah.
arbitrary. Like how many, you could
Wow.
have 20 ranks, you could have 5 ranks. Like it's,
Like
again, it's
I get
human
that it's
construction.
arbitrary, but when you zoom out of it and you look at it from a macro level, it works so good, right? It's just that when you zoom in, you realize that they're at fine resolution, that it is a spectrum, like you were saying, that there's
Yeah.
stuff that's in between, right? So then what about, how do you feel about, or can you speak to, it's much easier to get your head around that it's a spectrum between what's a algae and a whatever, an amoeba or something. I guess like I can understand that, but what about when you start to, that's a terrible example, but when you start to get to what's alive and what's not, that I want to be more clear than it is. And
Oh, everyone wants that to be more clear, but life doesn't
right.
work that way. It doesn't
So when
exist
I
to make
start
our
to,
lives easy.
I was talking to a virologist recently, and I was saying, like, are viruses in the phylogeny of life? I still don't fully like feel clear on this, but like when you were talking before about I think you were saying the tree of life or whatever, however you want to say
The
that, the big
shrub of life.
phylogeny, yeah, the Schweb of life, the phylogeny of life, right? Bacteria, like very clearly alive. Viruses, it's kind of weird. And then I really want to get into this thing of prions because I'm like,
Uh-huh.
WTF? Like, what is this thing? How
Uh-huh.
and how is it so outrageously destructive
Uh-huh.
and pathogenic and yet not alive? And then
Uh-huh.
how can they even be in the environment? So, can you speak to that first part about like what's alive and not, and then let's get into these thing on prions.
What's alive and what's not alive? Okay, well,
And does that matter? Do you think it matters? Or are you like, oh no, like it's a spectrum between rocks and people? Like, you know what I mean? Where does the
so
spectrum part end?
yeah, you could absolutely look at it that way. The spectrum analogy fits to pretty much everything, everywhere, at all times. There's never going to be somebody who's going to say, "Oh, no, it's not a spectrum." Well, maybe that's not exactly true, but it seems to be. The more you look, the more it is true.
Yeah.
Viruses are probably the place where I would say it's hardest to say if they are alive or not alive. In the old days, I think most people, by old days, I mean maybe 19th century, early 20th century, most people would have defined alive as does it have a cell? If it has a cell, it's alive. And if it doesn't, it's not alive. But then viruses were discovered around that time. And they behave in ways that are very similar to living things. They reproduce and they mutate and they have genetic information in the form of DNA or RNA, just like we do.
Which to me is like, regardless of whether you have a cell or not, I mean, I'm standing on the shoulders of giants, so it's easy to say it here as a Monday morning quarterback phylogeny. But to me, it seems like if it has genetic material code, a rock has, chemical structure, but it doesn't have code,
Mm-hmm.
right? So that to me seems like, but anyway, sorry, I got you off track. Go ahead.
Oh, no, it's okay. So here's the crux of the problem, right? Viruses can't exist without our cells.
Right.
So if they can't exist without us, are they alive? I don't know the answer to that. I honestly think, people who thought seriously about it could come to reasonable conclusions in either direction. You can decide for yourself. Do you feel that a virus is a living thing, or do you not feel that it's a living thing? It's almost philosophical at a certain point.
Yeah. Yeah. Yeah, it's like a seed, though. Like a seed is a living thing, but it requires the substrate, or else it'll remain dormant, right? So
That's true. But the thing that it requires is a non-living thing. It requires earth.
true, and it will turn into a
Well,
very obvious organism,
yeah,
whereas a
yes.
virus does not really do that. Just produces
Well,
particles, right?
it reproduces itself. It makes copies of itself. just like a plant makes copies of itself. So I feel like, I'm kind of agnostic on the question of viruses. Are they alive or not alive? It's not necessary for me to enjoy them to have a definitive answer to that question.
Right.
If enjoy is the right word when applied to viruses. But
I
I
can
guess
appreciate,
when you're a
philosophically.
connoisseur of biology, enjoy can be the right word occasionally.
Yeah, exact connoisseur of biology. I think that philosophically having the mystery is important. We're so engulfed in data now, like having something that's mysterious there's something really, I think like if we were to dissolve all the mystery, we might find that we wished we hadn't, like it might be really important to our psychological well-being to not
Like
know.
if we
But
answered every scientific question that could
yeah.
ever be asked and we got
Mhm.
to the end of the book and we wrote the last word, wouldn't we feel hollow and empty inside that there was nothing left
Yeah.
to find out? Yeah.
I think probably, yeah. Okay, so viruses, they have code, they replicate themselves.
Uh-huh.
What is a prion? And I'm bringing this up. I want to make sure too that I give some make this relevant for everybody. As a hunter, I'm
Hmm.
blessed and lucky to be here in the Northeast, where we don't have chronic wasting disease
Yeah.
yet in the state of Maine, but we recently had just over the border in Quebec, there was a case where that was the closest it had gotten to us. And obviously, the states are kind of scrambling to figure out how to deal with it.
Hmm.
Of course, this is a prion disease. And the other strange part that we can get into after is sort of what's going on with this meat, because a lot of hunters are harvesting animals that do
Uh-huh.
have chronic wasting disease and they are consuming them. And a lot of people aren't. And a lot of states are starting to offer testing.
Yeah.
But we have a lot of people out there who could be ticking time bombs, or maybe they're not. Maybe there's no species jump. So this is becoming relevant because it's going to change, and it's easy if you don't, if for people who don't hunt, it's like, oh, whatever, if hunting changes, whatever. It's like, well, some of us look at it like a continuous legacy that goes back, 3.6 million years. So to
Hmm.
me, it's a big deal when it starts to get interrupted in some way. But
Yeah. Yeah.
yeah, like what is a prion?
Uh-huh.
And then once we kind of establish that, I want to come back to chronic wasting disease.
Sure, sure. So a prion is, I guess the lay definition is it's a misfolded protein. Now that's not exactly really what prion is. The original prion is a very specific protein called prion protein. And it's actually a protein that is one of the many tens of thousands plus proteins that your body makes. And it does something that seems to be not particularly important because they've actually done experiments in mice, again, because it's convenient, where they've knocked out this protein and it doesn't actually seem to cause that big of a problem for the mice. They more or less go about their business. But
So it's a
I,
mammalian protein. It's common amongst
yes,
mammals.
yes, it's common amongst mammals. And that's actually part of the key to why it's caused so much mischief. Um, However, when this protein gets, let me back up one step. Proteins are strings of amino acids. And just for our purposes, all that you need to know about amino acids is that they're like little beads that are popped together, like those little pop beads that kids play with. And a protein is a long strand of these pop beads, maybe, I don't know, 300 long, say, 300 pop beads in a row. And when a cell manufactures a protein, it sort of spits out this line of pop beads, but each pop bead has a special side chain, is the word they use in biochemistry, a special little attachment on its side that has a certain physical property. Either it repulses other side chains or it attracts them. And that particular combination of pop beads in a certain order determines how that protein will spontaneously fold once it's manufactured. So all you have to do, if you're a ribosome in the ER, in the plasmic reticulum, is just you read that messenger RNA coming out of the nucleus and you spit out these pop beads, and magically, just because of the properties of these side chains, it folds into the proper shape. Now, that shape usually looks more or less like a blob to us, but it's a very important blob because that shape is vital to the function of that protein and how it interacts with the world. In the case of prion protein, that shape changes. Now, that's not unusual. Most proteins are capable of changing shapes, and in fact, the shape change is vital to how they work. The problem with the prion protein shape change is that it falls into a trap. It changes shape in a way such that it can't change back to the proper shape. And this shape is capable of catalyzing the misfolding of the next prion protein that it bumps into.
Without an enzyme.
Without anything. Just by bumping into, somehow, another prion protein that's folded correctly, this new prion protein will switch over to the misfolded shape, and now it's a prion as well. And as you can see, if you think about it, this will quickly become a chain reaction as 1 becomes 2, 2 becomes 4. Now, the reason that a lot of the diseases caused by prions have such a long incubation period is that the early stages of this chain reaction take a really long time. It takes a really long time for that first misfolded protein to bump
reach
into,
like a critical threshold.
To bump into the next one, and then for that one. Yeah. But then in the later stages, when suddenly there's lots of this stuff around, it goes really, really fast. So by the time that most people are diagnosed with prion disease, they don't have much time left. And
now, why don't we say what those diseases are too, just so that folks are on board with what we're talking about. I should have done that in the beginning, but
sure. So there are several prion diseases. There's one, none of them have particularly easy to pronounce names. There's one called Creutzfeldt-Jakob disease that is a familial disease. So this is a disease in which the people in the families have mutations that cause these misfolds, and it's passed down from generation to generation. Another one is called variant Creutzfeldt-Jakob disease, but that is just a fancy name for mad cow. And this was a disease that was caused when the prion disease scrapie in sheep was transmitted to cattle by contaminated feed. Cattle, by the way, are vegetarians. They're supposed to eat grass, but in certain instances in the United Kingdom, they were fed blood and bone meal from other cattle or from sheep, and these prions had gotten ground into this stuff, and it caused the disease in the cattle. And then when those cattle were harvested and turned into meat, people got the prions and ended up with mad cow disease. And remember, going back to what we said, that this protein, the prion protein, is common in mammals. The reason it has caused mischief is because our versions are close enough that when we, apparently, when we consume these misfolded versions from a cow, it's close enough that it can cause the human version to misfold.
So you eat the cow, the beef that's contaminated with the prions, and because you already have prion protein in your body that's there for some other purpose unrelated to any of this, doing its thing, but one by one they get converted to the dark side.
Yes.
By these folded prions.
Yes. And I think in the case of mad cow, its incubation period was much shorter than what's typical for some of the other diseases. Okay. Another one that I should just mention briefly is Kuru. And this was a disease that happened in Southeast Asia, where there was a cultural practice to consume your deceased relative as part of the funeral celebration. And when the brain was consumed by, the living, the bereaved living descendants or family and friends, they would develop this prion disease as a result of eating that.
I just try to imagine, like people being like, hey, maybe it's because we do that one thing that no one else does. It's like, no, it couldn't be that. It couldn't be that. It couldn't be from the long pig that we eat.
They may have been so isolated that they didn't know that no one else did it. I don't know.
Yeah. No, I mean, it's just fascinating. And then I guess you only need one exposure then, right? It's not like you need multiple exposures.
Well, I don't know. I mean,
is anyone immune?
These are questions that, as far as I'm aware, we don't know the answer to.
It's
we don't know how much. We don't know how much you need to eat, and we don't know if there are certain people that are immune. That's an interesting question. I that would be fascinating to know, actually, if certain people.
So you get scrapie jumps from sheep to cows. Then that's the bovine what do they call it? Spongiform encephalitis, right?
Encephalopathy. Ugh.
Oh, encephalopathy. Okay, brain disease. All right, so
Mm-hmm.
spongy brain disease, right? Cow's
Yeah.
spongy brain disease, that means. Okay, then that easily jumps to people, to humans.
Apparently, yeah.
Now, okay, so now we have this prion disease that's spreading through cervids, and obviously we're consuming a lot of this.
Yeah. So the question you're asking is one that many people have rightfully asked. And the answer is we just don't know, which is so unsatisfying, right? Because, I mean, people have done, I think, studies where they've looked at consumption of deer and elk and to see if they could associate it with cases of prion disease. And so far, they haven't really found too much. But then you're like, well, but the incubation period can be really long
Is
sometimes.
long. It's
So what if
long.
we just haven't seen it yet because we haven't waited long enough?
And what if when
And
it arrives, we don't recognize it?
yeah. What if it's, because people do lots of things. How are we going to track it back down to like, well, 30 years ago, I was a hunter and I
Mm-hmm.
killed this deer and I ate it, like that's a really long time to
It's
have
a
to
long
conduct.
shot. Yeah.
Now, having said that, it's not impossible that we would be able to trace it that way. Um, I'm thinking of another story that you maybe were going to ask me about Alzheimer's disease and prion disease
Well, I really
being.
do want to talk about that, but can we first, before we go there, can
Yeah.
we talk a little bit about the hardiness? I mean, the
Oh, yeah.
incredible robusticity of prions, because most people are thinking, and just for folks listening, something that's come up on this show a lot is, in the process of being a hunter, you come across so many, and fishing, you come across so many parasites, macro
Mhm.
parasites that you see with your
Yep.
naked eyes, and you're like, that skeeves me out, but I know if I cook that, it's just more protein in there. It's not like something that's
Uh-huh.
going to infect me. There's an
Right.
assumption that comes from hundreds of thousands of years of living with fire that, oh, well, I'll just cook this thing, it'll be fine.
Right.
This is something else entirely, and this is what freaks me out so much. So as we get toward this idea of the medical side, I really want people to understand why these things are so impervious to, or how impervious they are.
Right. So this is actually the thing that attracted me to writing about prions, even though it's actually pretty far out of what I normally write about, which is, more the protisty, planty, fungusy kind of section of the shrub of life. Um, it's the fact that these things are they have incredible powers of endurance. I remember reading about this in college and just being blown away. Um, they can survive radiation, um, disinfection with autoclaves, with benzene, alcohol, formaldehyde. The standard surgical sterilization procedure for medical instruments will not kill them. I mean, there are very few things.
Why? Like when I cook an egg, right? I'm watching the heat denature those
Uh
proteins
huh.
right before my eyes. I can see it go from clear
Yeah.
to clouding up, and I watch that protein change. What's going on with this arrangement of amino acids that makes it that even gamma radiation isn't going to disassemble it in some way?
Well, I will answer that question, but before I get to that, I also wanted to mention this is part of the problem for elk and deer because they are also resistant to UV radiation and all the assaults of wind and weather and freezing and time. So when
Amazing.
an elk who's infected with chronic wasting disease drools on some grass, on the dirt, on the ground, or it dies and its remains decompose, the prions that were in that animal can survive for years on that spot.
Mm-hmm.
And when the next elk or deer comes along and maybe feeds on some grass or whatever in that area, they can actually pick up the disease even after the prion has been sitting there in the environment for a very long
Yeah.
time.
And what we're learning in the conservation world constantly is, or what we're hearing about now is, hey, this idea of a deer feeder. is also a great hub for sharing prions. They
Yeah,
share
yeah.
communal mineral lick. Now
Yep.
they're realizing, hey, wait a second, what about these urine-based lures that people are using?
Uh-huh.
Are they contaminated in the way that we now know we had contaminated blood and organs in the past, right? So it's like, oh
Right,
man,
right.
maybe we were actually spreading it around, putting this stuff on the
Uh-huh.
ground, and then a deer comes over to smell it, licks at it.
Yeah.
So,
Yeah, it's a
it's
legitimate worry.
environmentally pervasive, right?
Right. So your next question was how do they do it? And we don't know for sure, but my impression of what the best hypothesis is right now for what's going on is that prions don't generally exist as individual proteins after a while, we think. They tend to clump together into sheets. And also, the structure of a lot of the misfolded prions tends to incorporate a shape. In the world of biochemistry, they call it a motif. But basically, it just means a section of a protein that's folded in a certain way. And one of those motifs is called a beta sheet. And it's like a flat sheet where, if you can imagine like a string that's running back and forth in a line, um, that's not a great way of describing it. I'm trying to think of a better
Until it starts to
way.
form, until it starts to form like a laminar sheet because it's been
Yeah,
zigzagged so much.
yeah.
It's
A
not a
bunch,
tissue though. This is not a tissue like a.
no,
Okay,
it's not a tissue like a tissue in your body, but it's like a
it's a
section of the protein that's folded into it's a kind of a plane.
okay.
I guess one way of thinking about it is if you've ever looked at a loom and the warp threads on the loom they run one way and
Yep,
then they turn
yep,
around and they go back the other
yep.
way.
They just
And
keep doing
then
180s. Yeah.
exactly, that's the way to think about it. So that particular shape is really stable and it's really easily forms these big clumps or fibrils sometimes, long fibers. The bottom line takeaway is that they fold themselves into a big clump that's really stable. And that's part of the reason they can't be folded back into the correct conformation. But I think it also makes them resistant to all of these other assaults that we normally would think would quote unquote kill. Remember, not alive, the protein.
Not a lot on the
But
life spectrum. Somewhere
yeah,
on the life
yeah.
spectrum.
But I got to use a word. I guess maybe a
Yeah,
better word would be disable or
yeah,
inactivate.
yeah. Sure.
Inactivate,
Yeah.
right? So that is the current thinking, I think, on what's going on and why they're so resistant. Another idea that people have had is that the methods that we use to sterilize and decontaminate surgical equipment and all kinds of other things because our definition of life is based on having DNA or RNA, focused on destroying DNA and RNA, and proteins don't have DNA and RNA. So, the chemicals that we use to decontaminate are by definition designed to decontaminate a different set of molecules. So, it's in some ways, maybe it's not surprising that our methods don't work very well on prions.
But
But
additionally, I was reading in your article that they also bond unusually strongly to stainless steel, which is the
yes.
material that we choose for our surgical
That's right.
implements.
They do. And it's not exactly clear why that is the case either.
Of
Maybe
course not.
because of the big clumps. I don't know. I've never been able to see why. I've only ever seen that it's stated that they stick like glue is the word that people say all the time. But I've never seen anyone say why. They they seem to love stainless steel so much.
So one of the things a lot of people will ask me this because part of what I do is explore ecology from a culinary perspective,
Uh-huh.
which means I'm unlike my wife, who's a little more conservative about what she likes to eat. I'm sort of like somebody who likes to try a lot of different weird things. And one of the things that will come up is people are constantly like, "Do you eat brains? Do you eat brains?" And I'm like, "Look, I never eat brains. Like, I just don't mess with brains because of this issue."
Yeah,
You
I
know
would
what I
say it's
mean?
a best practice, really.
Yeah, I think it's a best practice to not eat the nervous systems of other, organisms
there's
when I
enough
can
to
help
other
it.
tasty bits that I'm okay with that. I'm okay with letting
Yeah,
that
because
section
my
go.
stomach acid is not going to break it down. My,
Yeah.
UV, gamma radiation, heat, direct fire, all this stuff, like none of that's doing anything, right? So
Hmm.
that concerns me. So, but what I understood today, just reading your article about Alzheimer's, is the idea that if you get in on my brain and do brain surgery,
Hmm.
and I have a prion disease, now these tools, the scalpel and probes, they have the prions on there. They're locked onto the stainless steel. And then even 2 years later, if these tools never get used for 2 years and they've been through the autoclave and they've been through all the
Hmm.
disinfectant, they still could possibly cross contaminate the next person who gets a surgery performed with these tools. Is that sort of the thrust of it?
That is correct if you use the standard cleaning method for most surgical equipment. But
Right.
I will say, I think brain surgeons are hopefully savvy to this issue, and they have developed cleaning methods that for equipment that is specially used for neurosurgery. The problem with these methods, which involve lots of either sodium hydroxide or bleach and heat and pressure, is that they are really hard on stainless steel. And
Yeah.
so I think it really shortens the lifespan of your very expensive surgical equipment.
Yeah, but at the price of brain surgery, it's like I think you can
Yeah.
throw in a scalpel.
Yeah. I think the World Health Organization has actually recommended that, if possible, they use disposable instruments for brain
Right.
surgery.
Yeah, that makes
Um,
sense to me based on this.
yeah, the question is, what about other surgeries that maybe aren't directly on the brain or the spinal cord? What about eye surgery?
Yeah.
There's been some recent discoveries that prions, in particular, the prion disease prion, is present in very large quantities in the cornea and the retina of eyes of
I
people
mean,
who
when
are
you
in.
start taking apart a head, you're like, hey, the eyes are part of the brain. They're
Yeah,
like
they
the
are. They
periscope
are.
of the brain.
But ophthalmologists are not the same guys as the brain surgeon guys.
Yeah, right, of course.
They haven't got the
That's those
memo yet.
categories we were talking about.
Yeah. And then I also just wonder about other tissues, we just don't know the answer to that question. Obviously the pathology of people with Alzheimer's and prion diseases, which we haven't explicitly stated yet, but there's a lot of similarity. They're both amyloid diseases. Amyloid is the science name for these big clumps of misfolded proteins. And in prion diseases, they collect in your brain. And in Alzheimer's and Parkinson's and Huntington's and a lot of other unpleasant neurodegenerative diseases, there's different proteins that are forming amyloids. In the case of Alzheimer's, I believe it's called amyloid beta, and there's another one called tau. In the case of Parkinson's, it's called alpha synuclein.
And this is
But
clumps of these misfolded proteins that are accumulating on neurons and between nerve cells.
in brain cells, around brain cells. Some of them are inside, some of them are outside, and they cause different kinds of clumps. They look different. I mean, in Alzheimer's, you have the plaques, which are caused, I believe, by the amyloid beta, and the tangles, which are caused by tau. But there's different versions of that in different diseases. I think in Parkinson's, they're called inclusions. And in prion disease, they probably have a different name. But it seems like they're all kind of different flavors of the same sort of thing. So there was a study recently where this is circling back to what I was starting to talk about earlier with this like long time delay and still being able to track down what happened. So it turned out that there were some people who needed to be treated with growth hormone back in the 50s, 60s, 70s, and 80s. And back then, before we had bacteria that we could put in tanks to make growth hormone for us, we had to get growth hormone from human cadavers. Well, that growth hormone was extracted from the brain. And it turned out that some of the people who got these extracts came down with prion disease and died as a result of this,
Wow.
long before their time, while they were still probably in their 30s and 40s. And it was realized, well, gee, we were treating these people with a brain extract. They probably got it by, being injected with this hormone. So as it turned out, they had actually saved the samples. I believe this was at the University of Oxford It was the National Health Service in the UK. And they had saved these things. They were sitting
Got
at
lucky on
room.
that one.
They had saved samples of the growth hormone at room temperature for decades. And they went back and analyzed. And sure enough, there was prion in these. But they also had discovered that some of these people had died early of Alzheimer's, at least a subset of Alzheimer's symptoms, I guess is the way I'll put it. And they said, maybe we should look at these extracts for amyloid beta. And they looked, and it was there. And that started to give them a very uncomfortable feeling because the logical conclusion of that is that Alzheimer's can be transmissible under certain circumstances. Now, important to
not
emphasize
obviously
here.
person to person, but
right. Very important to emphasize here. We are not talking about hugs and kisses. This is not the same thing as being contagious. But perhaps under circumstances where it's possible for tissue to be transferred, one of the most important procedures in the eye world is called a corneal transplant. And I guess these are becoming very, very popular nowadays. But remember what I said about the prions being really, really common in eye tissue. And now we know that potentially Alzheimer's can be transmitted by tissues from, and then you start thinking, well, what other, and we also know that prions can be transmitted through contaminated surgical equipment unless you do some really draconian sterilization on that equipment. And, the question marks just keep popping and popping and popping in my mind because, probably not a lot of Alzheimer's patients have brain surgery, but where is the cutoff between, being an Alzheimer's patient and not? And what if these, amyloid proteins are accumulating in other parts of the body in ways that aren't as visible to us, but they're still there?
Early stages, how would you detect it? Before detection was possible, you could be getting brain surgery.
Yeah, and it's not that I think that this is necessarily rampant, but you sort of are like, I hope somebody's investigating this. I hope somebody's looking at this question because Alzheimer's is super common. And how would you know how you got it, right? People always want to know, where did it come from? How did I get it? It would be very hard to trace it back to. And, no matter how rare these events are, if they are preventable, we should be preventing them. And so that I don't know. They also did one further experiment that I think is worth mentioning regarding those samples that had been kept in room temperature by the National Health Service. The next step was to take the samples and inject them into mice and see if they could show that it actually caused amyloid beta accumulations in these mouse brains. And bad news, sure enough, it did.
These were mice that were bred to develop Alzheimer's, or?
I am not sure the answer to that question. I will have to go check that.
Okay, that's interesting, man. Wow. Yeah, it's like, okay, so moral of the story, don't touch brains with grandma.
I think that's good advice at any time.
Yeah. No, it's a really eye-opening thing. And I think it's a little bit unsettling, but at the same time, if we could find an origin, that would really be helpful too.
I'm not trying to imply that this is the origin of the majority of Alzheimer's. The origin of majority of Alzheimer's is still a mystery, and I think it's likely to not be surgical equipment. But
no, I get that. But if we know that it's the amyloid plaque, and that we know that is, we could basically start to unravel it, right?
Well, that's another question. Actually, I should definitely emphasize there's a big school of thought that amyloid is the cause, but there's a lot of controversy over that. And there's a lot of people who say it's not, that it's just a symptom and not the cause. So Alzheimer's science is extremely complicated right now and very difficult to, everyone wants to know what causes it and how can we cure it. And I think that those questions.
You got to have also people who don't want any, one thing I've learned about science just from my, my lay perspective is that you inevitably you have the people who don't want the science to change, and then you have the people who are like radical and want to bring in a whole bunch of new ideas, but you get those people who are like, no, I don't like this, we like the track we were on, thank you very much. So
and it's very unclear to me right now which of those two schools is right. I think it's very much up for debate.
I want to ask you, I'm getting aware that I'm taking a lot of your time here, but I just want to ask you about another controversy that
Sure.
this is a very unrelated, it's related to you and your writing, but it's unrelated from a species perspective. But I'm going to jump all the way over to the Lyme disease spirochete.
Uh-huh.
And because you've written on that too. And one of the things that keeps coming up, being in the alternative health world, the number of people I meet who have what they call chronic Lyme disease.
Uh-huh.
They have neurodegenerative issues that they are sure is from a chronic Lyme infection that had gone undiagnosed. Then when I speak to professionals, they constantly tell me, no, there's no such thing. It's in these people's heads. So most of these folks have been bounced around from doctor to doctor until they find somebody who says, hey, this is an undiagnosed Lyme issue. And then they do some pretty intense treatment. Whether or not they recover, it's always difficult for me to tell. It's like anecdotal stuff.
Mm-hmm.
But so I'm hearing that, these two extreme arguments. One is that, you can get a spirochete infection that goes undiagnosed and spreads throughout your body, slowly destroying your nervous system or your heart or something like that, getting into your joints. And then I have folks in the medical world who are like, nope, your body eventually clears it and you're good. And I'm just curious if you have any thoughts about that. Because I'll say that there's a lot of people who have related spirochetes to things like Alzheimer's and other neurodegenerative diseases too.
Yeah, Alzheimer's is such an enigma. People have looked at all kinds of causes, and it's really hard to say, still really hard to say. I will be fascinated. I hope they figure it out during my lifetime because
Right.
it's truly mystifying. But to get back to your spirochetes question, I haven't actually written on this topic ever. The only time I wrote about spirochetes was in regard to their propulsion system, and which is really fascinating actually, and is part of the reason that they can become quickly so pervasive in people's bodies. Now, the answer to the question about whether it can be a chronic infection, I don't know the answer to. Um, I think it's possible, but it's also possible that what they are experiencing is more of an autoimmune disorder where they did have Lyme disease at one point, and that bacterial infection triggered an autoimmune response to a similar target in their own bodies. And
Mm-hmm.
long after those bacteria are gone, the immune system is still reacting as if they're there.
Like
Now,
an
that's just,
echo.
yeah, yeah. And I think there's a lot of other immune diseases, autoimmune diseases, where that is the suspected mechanism. There's been some discussion about that with regard to type 1 diabetes. There's been a lot of suspicion that there's an underlying genetic susceptibility and then a viral infection is the trigger.
Wow.
A relatively minor viral infection may trigger the body to attack those pancreas cells because they just happen to look like a piece of that virus. And something similar may be going on with Lyme disease and the symptoms that people are reporting as chronic Lyme. Again, I'm not an expert. That's just a suspicion that I have.
I want to give you the floor to talk about kind of anything else that comes up for you. And one of the things I wanted to say is you had mentioned that Scientific American had kind of concluded their blog section. And
Uh-huh.
so I imagine you're experiencing sort of like you're quite freed up from what you were doing for a while. So I'm curious, like
as freed up as you can be during a pandemic with a 10-month-old baby.
yeah, free. That sounds easy. But what's on the horizon for you? What are you excited about? And are you continuing to write? Are you taking a hiatus? Is your fascination continuing to carry you into new territory, or what's
Yeah, yeah,
on
yeah.
the horizon for you?
So I absolutely am still writing. No plans to stop. I'm still planning to write for the opinion section of Scientific American, essays or columns, depending on how you look at it. I've written one already about the brittle stars that we were talking about earlier, and the fact that they can see with their whole bodies, which I think is pretty fascinating. And I've got more posts or more
What does
essays.
that mean, by the way? What does that mean?
Okay, so they don't have eyes. You got it so far?
Yeah,
No
yeah,
eyes.
I'm
But
with you. Yeah.
they have little light receptors over their
Okay.
entire body. And they, based on experiments where we put them in a ring with a black patch to simulate wreath shelter, they can consistently find that black patch on the side of the ring. So they apparently can see, by which I mean form a resolvable image with their entire bodies, like a
Wow.
very large array telescope, where you have a bunch of little telescopes that just get a pinpoint of data spread out in the desert, except on the surface of a brittle star. In my blog post, I shouldn't say blog post, in my essay,
In my
uh,
column slash
in my
essay.
in my column, I compare them to a squirmy but strangely cute Eye of Sauron. Their entire body is resolving an image, apparently, of a
And
wreath.
you could cover parts of their body and the other parts will still be able to resolve an image.
Yeah,
Do they
it
need
seems like that might be the case because in a brittle star, which has 5 arms usually, um, the arms operate semi-autonomously. They're almost like 5 co-joined organisms with mutual goals.
Wow.
And so the idea is that maybe from one arm to
Wow.
the next, they're actually even comparing images. Do they have something like
Wow.
binocular vision? It's kind of crazy.
You're never going to run out of topics.
I'm
I mean,
never
it's
going to
just
run
so
out of
rich.
topics. There's just so much cool biology out there that no one is writing about. It's
It's so
awesome.
true. It's so
So,
true.
the other answer to your question is I'm also working on a book. I'm finally getting around to writing my first book, and I've had it planned for 5 or 10 years now that I'm going to write a book about slime molds, and I'm doing it. I'm about halfway
Why
done.
slime molds? Talk
Yes.
to us about slime molds. What's the synopsis?
Okay, so slime molds are giant crawling amoebas. That's what they are.
Oh.
And
Whoa.
they have,
Wow.
so they're like, if I was to pick one organism that kind of crystallizes everything I love about all the different things I write about, it's the slime mold, because it is both a quote protist, but also a macroorganism that you can see with your own eyes. And it has all kinds of surprising behaviors
It's
that,
an individual?
yeah, and it can make choices about it's moving around its world. They can solve mazes, they can tell time, they can drive boats. There's all kinds of cool things that slime molds can do. And they have a totally bizarre way of life, and they're beautiful. And they're beautiful in like different ways in different times of their life. I mean, there's just I could go on and on. I will in my book. Please buy
Wow.
it. In
We're looking
about
forward
two
to
or
it.
3 years when I finish.
No rush then. Uh, I I often put scientists in this awkward position, but I'm just curious what you think about the incredible diversity, beauty, complexity, and intelligence of life. Do you think that there's how do I say it? How do you think this arises? Where do you think this comes from? How is there so much complexity, order, information, and intelligence? And do you think that we have any sufficient theories as to the origins of life?
Oh, wow. Talk about your deep questions. Well, I know that there's a lot of people that are fans of the panspermia hypothesis, the idea that life seeded itself through the universe. And, there was maybe life on Earth came from somewhere else. And for a long time, I thought that was pretty tinfoil hat. And I also have been not very impressed. It's a lot of people are excited about the idea of finding life on Mars. And that's never been exciting to me. I've always felt like, have you seen what we've got right here on Earth?
Yeah.
That we haven't even
Yeah.
finished studying yet? It's
Yeah.
amazing. Why is it necessary to find it on another planet to be amazed by it? But I will say that there has been some science that happened a long time ago and just recently that I recently wrote about that has kind of maybe changed my mind on that panspermia thing. Um, about a year ago, I found a paper. I just love finding these kinds of papers. It had been written in 1931 by this guy named Charles Lippmann. And he had noticed in his lab that there were bacteria that could survive for like 40 years in a totally dormant, totally dry state. And he thought to himself, well, if they can survive 40 years, what's the limit? Is there any limit? And he decided to be really ambitious about this. He went and got samples of coal, really old samples of coal, and he sterilized the heck out of the surface. I mean, he really went all out on the surface sterilization. He
So
crushed.
that he wouldn't have a cross contamination of some
Right,
kind.
right. And he had got these coal samples like directly from deep inside the earth, like thousands of feet down. And he crushed them up and he heat treated them, or not heat treated. He crushed them up and he soaked them in water for like a day or two. That was important. If he didn't soak them in water, it didn't work. And when he plated that crushed coal that he'd soaked for like a day or so in water on petri dishes that had food in them, bacteria grew. And these coal samples were 300 million years old.
Wow.
And I was just like, wow, 300 million years old. That's 50 million years before the dinosaurs even evolved.
Right.
This is the Paleozoic. And I started looking around, and there were these papers that had been done recently where they started looking in ocean sediments, and they had found bacteria that were capable of surviving several million years. And just a few weeks ago, there was a new paper from some scientists in Japan where they had looked at sediment at the very bottom of the bed of sediment, right up on the bedrock on the bottom of the ocean, 100 million years old, and they were able to bring bacteria back to life from that sediment. Wow. And I started to think, okay, maybe Lippmann wasn't crazy. This is amazing. This effectively means bacteria can be immortal under the right conditions. They're almost like elves, you know, unless killed in battle, right. They can live forever. And that is amazing. That means there are cells on the planet that started their lives before the dinosaurs evolved, that could start growing again tomorrow. I mean, if that isn't cool, I don't know what is.
Have we contaminated the moon, I wonder, with, you know what I'm saying? Like,
yeah, probably I remember, we have.
Yeah, a couple months ago, or maybe a year ago, I remember seeing an article about water bears and had we sent them into space. And yeah, so it's interesting because if we've already jettisoned some organisms off planet, you know, it's like.
But getting back to the where does life come from? When I saw this science, I started to think, well, if the asteroid is big enough and the life is deep enough inside of it to be protected from cosmic radiation, maybe this is the way that life spreads around the universe. Yeah. But then you still get back to the question of how did it start, you know.
You just kicking the can down the road, but it's something.
Yeah.
It's something better, because I don't know if there's like you said, there's no governing body who decides what the current theory is, I guess. But I mean, growing up and hearing like, well, maybe lightning struck the primordial ooze was always like, that seems like a Frankenstein novel to me. I don't know about that.
Yeah, there's so many ways it could have started. I mean, again, is it necessary to know to enjoy it?
No.
Why not let there be mystery and magic?
Mm-hmm. Yeah. Last question for you. When I talk to a lot of folks in the conservation and biology world, there's so much concern about the state of the environment, the climate, the planet.
Yeah.
Particularly, I think it's easy to be like climate. And I think that a lot of times more educated folks are going like, hey, habitat, you know?
Mm-hmm.
But your focus being on organisms that are largely, if I hope I'm not speaking out of turn here, but it seems like a lot of these organisms are fairly impervious to the kind of things that we've been doing to alter the landscape. Mm-hmm. So I guess, like, I often ask people, are you optimistic or pessimistic about the future of the planet ecologically, about our place in it? You know, do you think that we can kind of pull back from the damage we're doing, or do you think that we are already in like a chain reaction that we are maybe too far into to ever control or stop? And I'm curious your perspective on all that, given the unique organisms you look at, because, you know, if you're into rhinos, it looks real bad right now.
Yeah.
But if you're into slime molds, it probably doesn't look that bad.
Yeah. The slime molds are going to make it no matter what we do. I have no worries about slime molds. I understand what you're saying, though. I, like most people who have thought about it and considered the science carefully, am very concerned. it's not that I don't think that life is going to continue. It will. Life is going to make it. I mean, life has made it through way worse than what we're going through right now, many times. The question is, do we want the planet to be a nice place for us to live as humans? And a recognizable place, a place that's comfortable for us and that can sustain us in a way that doesn't lead to lots of conflict. And I think the answer to that question is we do. And if we want that, then I think it's important to try and combat the forces that are causing the climate change, the rising carbon dioxide and other greenhouse gas concentrations. I like the planet the way it is. I like the planet that I grew up on, the one where I could be in the forest and relax and breathe and look at the trees and not be subject to horrible, unexpected weather, whether that be heat waves that are longer and hotter than, we're used to, or severe storms, or whatever the manifestation of climate change is. Obviously, there's many manifestations of climate change. I think that a lot of organisms, maybe not slime molds, maybe not cockroaches, but a lot of them are going to have challenges adapting. Others will benefit. There will be winners and there will be losers, just like anything. I don't think that we have gone too far. I don't ever think it's too late to try and do the right thing.
Beautiful. Thank you. I really appreciate your perspective and your attitude about that. It's awesome. It's just always nice to hear. Where do people stay abreast of what you're writing and stay on top of your projects? Do you do social media at all? Or
yeah, so the best way is Twitter right now. I have a Twitter account, and anytime I do anything, I post it to my Twitter feed.
Oh, great. What's your handle there?
At Jennifer Frazer, my name. Frazer is Frazer, no I. Just all run together. And that's where I post to all my latest projects and anything else that I think is interesting. And if anything changes with me, that's where it'll be.
And then the archives of all the stuff that you've written, they can find by just searching the Artful Amoeba, correct?
Mm-hmm. Yep.
Yeah, you have a great catalog of stuff there. So I've been going through article by article. And
11 years worth. It's a lot of stuff.
It's really cool. Jennifer, thank you so much for being here, and thank you for what you do. You're just a really cool person, and you make such a unique and special contribution. Really, I mean, a really cool special contribution. Like you said, this is stuff that a lot of people are just not. It's not like they're not interested. They're missing out on this really wonderful stuff, and I just appreciate that you're bringing it forward. So thanks for progressing the work in this area.
Well, thank you for giving me a platform to further spread the gospel of awesome life.
Thanks for listening to the WildFed podcast. You can help us grow this show by subscribing and leaving us a rating and review. It ensures better rankings and more advertiser interest, which translates directly into better shows, more awesome guests, and a constant stream of fresh, new content. Have a question you'd like answered on the show, or a hunting, fishing, or foraging trip you'd like to host us on? Email us at info@wild-fed.com. And be sure to visit our website, wild-fed.com, to check out the WildFed video show and store. WildFed. Food is all around you.